Hello friends, so let's talk about the assumptions and residual plots for one-way Anova. Let's return to ABC, the manufacturer of nylon automobile safety belts, where the quality engineer has been testing fiber samples to determine which of the company's 5 suppliers provides the strongest material. In the previous lesson, we used one-way Anova to test the null hypothesis that the average tensile strength of each group of fibers is the same. And then we use multiple comparison to determine that the supplier 1 and 4 provide the strongest fiber. So now that we have completed our evaluation, so how do we know our results are trustworthy? We can verify these assumptions by examining the residuals of the data. They are calculated by subtracting the observed value from the fitted value. When the sample size is the same for each group, the fitted value is the group mean. The residuals are estimates of the error in the Anova model. All hypothesis tests are based on one or more assumptions about the data. If our model violates these assumptions, the results of the analysis can be misleading. For ANOVA, there are 3 specific assumptions about errors. They are random and independent. They are normally distributed, and they have constant variance across all factor levels. The first assumption states that errors are random and independent. To ensure that the sample data are random, we collect data using random selection techniques. It's possible that the data may not be random, but good sampling techniques will ensure they behave as if they are random. This will minimize the chance of selecting a sample that is not representative of the population. The independence assumption specifies that the errors are not affected by the order of data collection. To check this assumption, we can plot the residuals in the order that the data were collected and look for any patterns. The order is determined by how the data are entered into the worksheet. If data were not collected in any meaningful order, or if the order the data were taken in is unknown, so do not use this plot. Here are 2 residuals versus order plots. The points on these plots fall in a random order and don't exhibit any patterns. The residuals appear to be independent of one another. This plot indicates that the residuals may not be independent. The points are gradually decreasing over time, and this plot exhibits a problem. There seems to be an updraft shift in the residual values. If we detect patterns in the residuals versus order plot, we should determine the cause. Possible causes are the omission of an important variable or problems during the data collection. Here is a plot for residuals versus order for the data. So do the points appear to be randomly distributed and independent? The residuals appear to be randomly distributed and no unusual patterns exist. We can assume that the errors are random and independent. The second assumption states that the errors follows a normal distribution. To test this assumption, we can use a normal probability plot. If the residuals follow a normal distribution, they should approximately follow the straight line on the plot. Here is a normal probability plot. It describes residual that likely follow a normal distribution. We can see that this residual approximates a straight line. This plot exhibits patterns that indicate the residuals do not follow a normal distribution. The third assumption states that the variance of the R spread in the errors across all factor levels is constant. To check this assumption, we can plot the residuals versus the fitted values. Notice that the residual versus values are on the vertical axis and the fitted values are on the horizontal axis. Remember that the fitted values are obtained using Anova model. This plot demonstrates constant variance across the factor levels. The scatter of the points around the line is similar across all factor levels, and no unusual patterns in the data are present. And this plot demonstrates a common problem. The residuals increase systematically with the fitted value. Which is sometimes called the funnel or megaphone effect. For the ABC example, the residual plots show that all three assumptions for Anova are met. The errors are random and independent, are normally distributed, and have constant variance across all factor levels. Therefore, we can use the Anova results to make decisions about which supplier to use. So let's review. We learned that there are three key assumptions about the errors for an ANOVA model: that the errors are random and independent, the errors are normally distributed, and the errors have constant variance across all factor levels. If the model violates this assumption, the results of the analysis can be misleading. We can examine the plots of the residuals to check the ANOVA assumptions. Thank you for your listening. In the next lesson, we'll talk about the two-way ANOVA.